So this lesson is focusing on how to write the equation for a line given lots and lots of different types of information. Okay, if you look at the examples on the back of this page, you'll get an idea of kind of what we're talking about. And there's really not a whole lot of new math. We covered the new stuff up here yesterday in class, so I'm going to skip over that for now. But I kind of want to go to this section down here where I just want to talk about a general strategy anytime you're being asked to write the equation for a line. Okay, writing the equation for a line, if we want to write it in y equals mx plus b form, we need two things. And probably the most important would be we need the slope. Okay, so I just wanted to run down a list of some ways that we could be asked to find the slope. First off, sometimes it's just given to you. And I kind of refer to these as the silver platter moments. Because this is when they just say, hey, here's your slope. Your slope is 5. Your slope is 2/5, things like that. Okay? So sometimes it's just handed to you. Sometimes they give you 2 points on your line. And if you're given 2 points, then you can do the y2 minus y1 over x2 minus x1 that we've been doing quite a bit of. Okay? If they give you a graph, you can just count the rise and the run from the graph. Okay. They may also give you a line that's parallel, which remember means you're going to keep the slope the same. Or they could give you a line that's perpendicular. And that's when you're going to do the opposite reciprocal. So if it's one of these two situations, parallel or perpendicular, what you're really going to be given is another equation for a line that you have to pull the slope out of and then turn it into a different equation. And so we need to know how to get the slope out of an equation. Equations can show up two different ways. It can be mx plus b, in which case the m is just your slope. Or if it's in this standard form, like this, we had talked about a shortcut where you can just do negative a over b. Okay. So if I give you a parallel line and it's written like this is how you would pull the slope out. If I give you a perpendicular line and it's written like this, you would pull this slope out and then do the opposite reciprocal. I hope that that makes sense, but I think once we start doing the examples, it will. Okay. Once you have your once you have your slope, we need to find a y-intercept. Okay, and y-intercept is a little more straightforward, because you only have two options in terms of the y-intercept. Either you have it, it's given to you in the problem, or it's not given. If it's given, then you just jump straight to y equals mx plus b. If it's not given to you, that's when you're going to do what we talked about up on top here. In class, is you're going to plug in your coordinate. You're going to plug in some point and solve for b. Because by that point, you should have your slope from up above. Okay, so up here we found the slope. So you can plug in your slope and a coordinate, solve for b, and then once you have your b, then you can head over to this y equals mx plus b form. So this is kind of where you're ending the process. Okay, so we find a slope one way or another. Okay, and then we find our b value. Either it's given to us in the problem or it's not given, and then we solve for it. And then we can write our equation, y equals mx plus b. Okay. Now, one thing I want to talk about, and I'm going to kind of write this off to the side here, is there's some unusual situations, and I shouldn't say unusual because they pop up fairly often, but there's some types of equations that don't really fit this mold, and that would be our horizontal lines and our vertical lines. So if a problem tells you that you have a horizontal line, okay, I want you to know right away that that's going to be a y equals some number equation. And you should also know that that means our slope is equal to 0, that all three of these things kind of go together, okay? So sometimes I might say, hey, write me an equation for a line with a slope of 0. I want you to know that that's a horizontal line, and I want you to know this is what the equation looks like. If I throw you an equation that looks like this, I want you to be able to tell me that the slope is 0 and it's horizontal, okay? So you need to know that all three of these pieces of information kind of go together. And then same thing for your vertical lines. Vertical lines, remember, are x equals a number, and they have a slope that's undefined. Okay? And so these three pieces of information go together. So when you have something like this, if you have a horizontal line or a vertical line, I want your brain to immediately step off to the side and say, okay, I know what my equation is going to look like now. Okay, so let's talk through a couple of examples here. And you're welcome to pause the video if you need a second to catch up on writing that down. In our examples here, example 1, like I said, my first goal with every one of these is to figure out what my slope is, okay? So for this one, I'm given 2 coordinates. So to find my slope, I would dive in and go 8 minus 4 over 2 minus 6. Okay, y2 minus y1, x2 minus x1. 8 minus 4 is 4. 2 minus 6 is negative 4. And then this gives us an overall slope of negative 1. All right, so I've got my slope. Step 2 is y-intercept. Okay, and I'm not given my y-intercept here, so that means I have to find it. So I'm going to say y equals mx plus b. I'm going to plug this negative 1 in for my slope, okay? And then for x and y, I just need to pick one of these 2 coordinates. It doesn't actually matter which one. So I'll go with the 6 and the 4. Remember, 6 is my x, 4 is my y. And now I should be able to solve for b. So now I have 4 equals negative 6 plus b. Add the 6 to the other side, and I get 10 equals b. And so then my third step would just be to write my equation. Y equals negative 1x plus 10. Oh, I'm going to run out of room. Ugh. Negative 1x plus 10 there on the edge. Okay, so these are kind of the 3 steps you go through every single time. Now sometimes the equation or the problem is just going to tell you what the slope is, so then you don't have this first step to worry about. Sometimes it's going to tell you what the y-intercept is, so you don't have to worry about the second step. But this is kind of the whole process beginning to end. So with this next one, to find my slope, if I want it to be parallel to this, okay, what I really need to do is find the slope of this line. So this is in standard form, so I'm going to do negative a over b to find my slope. So that would be negative 3 over my b value of negative 5, which I'm going to say is 3 over 5. So there's my slope. Step 2, y-intercept. And again, I'm not given my y-intercept here, so I'm going to say y equals mx plus b. I'm going to fill my 3/5 in as my slope. Okay. And then here's my x and my y. So I'm going to go negative 4 equals 3/5 times 10 plus b. 3/5 times 10 is equal to 6. and then subtract the 6 from either side, and I get negative 10 for B. Then I put together my slope and my y-intercept, and I say my equation is y equals 3/5 x minus 10. Okay, so when I get to that third one, I see this word, and immediately this whole process goes out the window for me. And not in a bad way, okay? Because these should be super easy. As soon as I see horizontal line, my brain is thinking, I know it's going to be y equals some number, okay? Because I know that's how horizontal line works. So then it's just a matter of looking at this and saying, well, what does y have to equal? Y has to equal negative 1. So my equation is just y equals negative 1. And I'm done. Okay, so looking at example 4, this one's not as obvious for how you find slope. If you think back to our list of all the different ways we could find slope, it doesn't fit any of those molds until you think about the fact that these intercepts can really be written as coordinates. So this is really the point 5, 0, and this is really the coordinate 0, negative 8. Okay, so my first step now, finding the slope, would look like this. y2 minus y1, so negative 8 minus 0, over x2 minus x1, so that's 0 minus 5. So I end up with negative 8 over negative 5, which reduces to 8 over 5. Okay. Now what I like about this problem is that my y-intercept is just handed to me. Okay, I have my y-intercept. It's given. So now I can just jump straight to writing my equation, and I can say y equals 8/5 x, because that's my slope, and then my y-intercept minus 8. Okay, so on that one I only had to do the 2 steps. Okay, so it's really like I skipped that middle step from up above. Okay, number 5, perpendicular to this line, okay, and then it gives us our y-intercept, so that's nice, right? My step 2 gets kind of eliminated here. But my step 1, to make this perpendicular, first thing I need is the slope of this line. So this line's slope is 2 over 3. And then remember, if I want to make it perpendicular, I need the opposite reciprocal. So I'm going to flip it over and make it negative. So I'm going to make it negative 3 over 2. Okay, so that's now my new slope. I have my y-intercept, so I can just jump straight to y equals negative 3/2 x. And then technically it would be plus 0, although we really don't need this plus 0 on there. You could just write it as y equals negative 3/2 x. But if you wrote it with a 0, that would be fine. Okay, and then number 6, line with an undefined slope containing the point 4, 2. Well, even though it looks like it gives us a slope, undefined is not like a number I can put in my problem, right? But this is another one similar to number 3 up here, that as soon as you see this, I want your brain working, okay? We're going to ditch all this other math, and we're going to say undefined slope we know would look like this. X equals a number. Okay, remember I told you to connect all of those things in your head? So then we just say, what would x equal? Well, x would equal positive 4. Okay, so these ones, like number 3 and number 6, should be the easiest ones. But they tend to be the ones that throw us off the most because they break the mold. Okay, they don't fit the pattern that all the other ones do. Okay, all right, so that's really it for today. Your quiz that, as of this year, is on Friday, covers problems that look just like these 6 examples. This is exactly what you need to know for your next quiz. Okay, so if you do have any questions, please feel free to stop by and see me or ask in class, whatever I can do to help you. Okay.